At 3:47 a.m. local time, a farmer in Lumajang heard what sounded like thunder, but the sky was clear. Then he looked toward Mount Semeru and saw something that made his blood freeze. A towering column of ash and fire shooting 3 kilometers into the sky, glowing orange against the darkness. I'm Irina Bondarenko, and what this farmer witnessed wasn't just another eruption. It was the trigger that is now setting off a chain reaction across the entire ring of fire. In the past 6 hours, seismic stations from Japan to New Zealand have detected synchronized tremors, all pointing to one terrifying possibility. Is Semeru's massive blast waking up volcanoes that have been silent for decades? And if this chain reaction continues, could we be looking at the largest volcanic crisis in modern history? Mount Semeru stands as Indonesia's most active and dangerous stratovolcano, dominating the landscape of East Java at a towering 3,676 meters, known locally as Mahameru, the Great Mountain. It forms part of the infamous Pacific Ring of Fire, where over 75% of the world's active volcanoes cluster along tectonic plate boundaries. What makes Semeru particularly threatening is its history of persistent activity. Unlike volcanoes that remain dormant for centuries, Semeru has been in almost continuous eruption since 1967. This constant activity has created a false sense of security among local populations who have grown accustomed to its rumbling presence. The volcano's typical eruption pattern involves small to moderate ash explosions every 20 to 40 minutes, with occasional larger events occurring each year. But on March 20th, 2026, the eruption shattered that predictable rhythm completely. The Indonesian Center for Volcanology and Geological Hazard Mitigation, CVGHM, had been monitoring increased seismicity at Semeru for weeks. Their instruments detected a surge in both shallow volcanic earthquakes and harmonic tremors, signs that magma was moving upward through the volcanic system. Yet nothing in their data predicted the scale of what was about to unfold. At 3:47 a.m., Semeru erupted with unprecedented force. Within minutes, a massive ash column punctured the pre-dawn sky, reaching 3,000 meters in height. Satellite thermal imaging showed surface temperatures exceeding 1,200 degrees Celsius, far hotter than typical Semeru eruptions. The ash plume, visible from space, began drifting southwest, threatening communities across 3 districts. Volcanologists are particularly concerned, not only by the eruption's size, but by its unusual characteristics. Dr. Herendeng T.S. Dion from Indonesia's Volcano Observatory notes that we are seeing magmatic compositions that indicate material from much deeper within the Earth's crust than Semeru typically taps into. Gas analysis shows sulfur dioxide emissions 15 times higher than Semeru's baseline. This suggests access to a previously untapped magma reservoir, possibly connected to deeper mantle sources that feed multiple volcanoes in the region. The most alarming scientific finding comes from seismic monitoring stations across the Pacific. Within 47 minutes of Semeru's initial blast, instruments detected synchronized low-frequency tremors at 14 different volcanic systems spanning the Ring of Fire. From Japan's Mount Fuji to New Zealand's Taupo volcanic zone, seismic signatures showed a coordinated pattern of pulses occurring at 11-minute intervals. This phenomenon, known as volcanic resonances, has only been documented twice in modern history, preceding the catastrophic 1815 Tambora eruption that caused a global year without a summer, and before the 1883 Krakatoa explosion that killed over 36,000 people. Professor Volkan Ates from the International Volcanic Research Initiative explains that we should think of the Earth's crust as a drum skin. When one major volcano strikes with sufficient force, it can create pressure waves that travel through the mantle and potentially destabilize other magma systems thousands of kilometers away. The immediate danger zone around Semeru extends 13 kilometers from the summit, where pyroclastic flows, superheated avalanches of gas, ash, and rock fragments, have already destroyed several villages. These deadly flows move at speeds exceeding 80 kilometers per hour and reach temperatures above 800 degrees Celsius, obliterating everything in their path. Lahar flows, volcanic mud flows composed of water and volcanic debris, present an even more widespread threat. With Semeru's eruption coinciding with the rainy season in East Java, these fast-moving rivers of concrete-like slurry can travel tens of kilometers down river valleys, burying entire communities. The Basuk Kobokan drainage channel, which experienced catastrophic lahars during Semeru's December 2021 eruption, is once again channeling destructive flows toward populated areas. Drone footage shows bridges collapsed, roads severed, and entire neighborhoods submerged in gray volcanic mud. Respiratory threats extend much further, with volcanic ash containing sharp, glass-like particles and toxic compounds spreading across East Java. Health officials report a 300% increase in emergency room visits for respiratory distress, with children and the elderly most severely affected. Indonesia's National Disaster Management Authority has evacuated 47,000 residents, but an estimated 100,000 more remain in potential danger zones. Evacuation efforts face mounting challenges as ashfall reduces visibility to near zero in some areas, and volcanic debris blocks escape routes. The synchronized seismic activity following Semeru's eruption has triggered emergency responses throughout the Pacific. Japan has raised alert levels for Mount Fuji. The Philippines has increased monitoring at Taal Volcano, and New Zealand has issued preparedness warnings for communities near the Taupo volcanic zone. Dr. Yoko Tanaka from the Pacific Ring of Fire Observatory explains the potential domino effect. Volcanic systems that were already near eruption thresholds may be pushed over the edge by this pressure wave phenomenon. We're particularly concerned about volcanoes showing increased gas emissions or ground deformation in recent months. Historical evidence supports these concerns. The 1991 eruption of Mount Pinatubo in the Philippines was preceded by a series of smaller eruptions across Indonesia. Before the catastrophic 1883 Krakatoa event, synchronized volcanic activity was documented across multiple Pacific island chains. If this chain reaction scenario materializes, the consequences could be far-reaching. Just 5 major Indonesian volcanoes erupting simultaneously could inject enough particulates into the stratosphere to temporarily cool global temperatures by 0.5 to 1.0 degrees Celsius. While this might sound beneficial in our warming world, the rapid climate disruption would devastate agricultural systems, unprepared for sudden temperature shifts. Indonesia's position as a critical global supplier of palm oil, nickel, and coffee means that widespread volcanic disruption could trigger economic shockwaves across multiple industries. The country produces 60% of the world's palm oil and 30% of global nickel supplies, both critical for food production and battery manufacturing. The communities around Mount Semeru have developed sophisticated adaptation strategies over generations. Traditional Javanese knowledge includes reading subtle environmental changes from animal behavior to water clarity as eruption precursors. The Tengger people, who consider Semeru sacred, maintain elaborate rituals to appease the mountain's spirits, while simultaneously incorporating modern evacuation protocols into their community planning. Yet even these adaptations may prove insufficient against an eruption of unprecedented scale. Historical records from colonial Dutch archives indicate that Semeru's last major paroxysmal eruption in 1885 generated pyroclastic flows that traveled over 20 kilometers from the summit, far beyond current evacuation zones. Modern monitoring technologies provide advantages earlier generations lacked. Indonesia's network of 127 observation posts equipped with seismographs, gas analyzers, thermal cameras, and satellite links provides real-time data to emergency response teams. Yet the current crisis reveals significant gaps in preparedness for multi-volcano scenarios. As evacuees fill temporary shelters in Lumajang, Malang, and Probolinggo districts, the Indonesian government faces difficult decisions about potential long-term resettlement. More than 80% of evacuees are agricultural workers whose livelihoods depend on the fertile volcanic soils around Semeru. The scientific community remains divided on whether Semeru's eruption will trigger a cascade of major volcanic events across the Pacific. Dr. Carlos Menendez of the International Volcanic Crisis Center urges caution against catastrophizing. He says that while we are seeing unusual seismic patterns, many factors determine whether a volcano actually erupts, and most seismic disturbances will likely dissipate without further activity. Nevertheless, the synchronized tremors have prompted unprecedented international cooperation. The United Nations has activated its Volcanic Emergency Response Protocol for the first time since its creation in 2019. Japan, Australia, and the United States have deployed additional monitoring equipment and emergency aid to potentially affected regions. Climate scientists are closely watching atmospheric data for signs of significant ash injection into the stratosphere. If multiple major eruptions occur, the potential for temporary global cooling could disrupt weather patterns worldwide, affecting everything from monsoon cycles to hurricane formation. For now, all eyes remain on Mount Semeru as it continues its explosive activity. Each passing hour without additional major eruptions provides hope that the Ring of Fire may return to its normal state of restless equilibrium, rather than cascading into a multi-volcano crisis. The Earth's geological forces dwarf human experience in both power and time span. What we're witnessing at Semeru isn't just a local disaster. It's a reminder of how interconnected our planet's systems truly are. At Earth Attacks, we're committed to bringing you the latest updates as this situation develops. Subscribe to join our community tracking Earth's most powerful forces. Follow our social channels for real-time alerts. Share this video to help others understand the science behind Semeru's awakening. When nature reveals its power, knowledge becomes our greatest defense.